Welcome to this calculus course. We will begin this course with a brief discussion on functions and limits. What is a mathematical function? We actually live in a sea of mathematical functions. All our interaction with our immediate surroundings can be linked in one way or the other with some mathematical function. For example, let's think about a student assistant working and earning $7.50 an hour. The amount of money the student makes actually is related to the number of hours the student works. And here is a relation. When the student doesn't work, the student doesn't really earn any money. The student works for 1 hour, the student earns $7.5, for 2 hours, $15, 3 hours, $22.50, and so on. Now, mathematically, we say that the amount of money the student earns is a function of the time in hours. Is that right? It's a function. What is the meaning that it is a function? That the amount of money varies. It depends. There's a direct relationship between the amount of money the student earns and the amount of hours that the student puts in. And we can write it like this mathematically: A of t. Now this is not A multiplied by t. This means A of t. A as a function of time is 7.5t. Now you understand this concept. A of 1 equal to 7.5. A of 2 equal to 15, A of 3 equal to 22.5, and so on. Now a function has an input and an output. In this case, the input is the time in hours and the output is the amount of dollars. When the input is 1 hour, the output is $7.50, and we say A of 1 equal to 7.5. Similarly, when the input is 5 hours, the output is $37.5, or A of 5 equal to 37.5. Now here we have a good description of a function. Now you are familiar with drawing the graph of a function, aren't you? Now what will be the graph of this function we just talked about, A of t equal to 7.5t? It will be a straight line, and the slope of that graph will be $7.5 per hour. It means every time the student puts in 1 more hour, the student takes home $7.5. So that 7.5 is actually a rate of change. The slope of the graph is a measure of the rate of change. When the input changes by 1 unit, how much does the output change? Okay, let's now talk about independent and dependent variable. In the function we just talked about, there are 2 variables. Time is a variable. The amount of dollars is a variable. Is that right? Now, one of them is the input. Which of them is the input? And which is then the output? Now, the input variable is called the independent variable. Why is it called the independent variable? Because the student or the people related to the student are free to decide the number of hours the student has to work. You see? And therefore, it is independent. And depending on the number of hours the student works, the amount of dollars depends on that. So in the function A of t equal to 7.5t, t is the independent variable because the student is free to choose the number of hours he or she wants to work. Is that right? Well, of course, the employer has to agree also on the number of hours. But that is independent. You can actually choose. And the output actually depends on the input. Therefore, the output is called the dependent variable. So if you look at the general expression that you're familiar with, y equal to mx. Y is the output, x is the input. X is the independent variable, y is the dependent variable. Always the dependent variable is the function value, right? Which is connected to the input of the function. The amount of money the student earns depends on the amount of hours he works, and therefore the amount is a function of the time t. Look at another example. The position x of a car moving at 2 meters per second is a function of time, and we can write it like this: x of t equal to 2t. The car is moving at a constant speed of 2 meters per second. That means every second the position of the car will change by 2 seconds. You have x of 1 equal to 2 meters, x of 2 equal to 4 meters, x of 3 equal to 6 meters. Each time t changes by 1 second, x will change by 2 meters, and therefore this 2 is the rate of change. Is that right? Each time the input changes by 1 unit, the output will change by 2 units. That's right. Time t is the independent variable, and x in meters is the dependent variable. All right. Having got some idea about a function, let's now talk about the domain and range of a function. All these ideas you know already, but let's refresh our memory on this. What is the meaning of domain of a function? Well, we said a function has an input and an output. Now, is it possible that all functions can have all possible numbers as input and all possible numbers as output? Well, not necessarily. So, the domain of a function is the set of all possible inputs for that function. Now, for the function we just talked about, a of t equal to 7.5t, what are the possible inputs there? Assuming that a student can work negative hours, we can say the input can be all possible values. Is that right? How about this function? X of t equal to 2t. Here the input is the time in hours and the output is position in meters. Now, I can actually use any value of t as an input. That will give me an output value. When x equal to 5, when t equal to 5, x equal to 10. When t equal to negative 5, x equal to negative 10 meters. So the position of a car can be positive x or negative x. That's right. So you can actually take any number from the set of numbers from negative infinity to positive infinity. It can be used as an input here. Therefore we say the domain of this function is the set of all real numbers from negative infinity to positive infinity. In the same way, your function a of t equal to 7.5t, the domain is the set of all real numbers. How about this? F of x equal to x over x plus 4. There is a little problem here. What is that problem? When x equal to negative 4, the negative 4 plus 4 equal to 0, and a 0 on the denominator of a quantity does not give you any meaningful output. You see, x divided by 0, we don't know what it is. Now, why? Now, think about like this. What is 2 divided by 0.1? Now, think in your mind. 2 divided by 0.1 is 20. 2 divided by 0.01 is 200. 2 divided by 0.001 is 2000. That means as this denominator gets very close to 0, 0.000000001, the value of that quantity will be very large, 200 million. And when x is very close to 0, the function value will be very large. And when x is equal to 0, we don't know what it will be. And that's the reason why we say a quantity, a number cannot be divided by 0. It doesn't give you any meaningful, understandable output. And therefore, you cannot use an input which does not give you a meaningful output. X equal to -4 is not in the domain of this function. Why is it not in the domain of the function? Because it does not give you a meaningful output. Now therefore, we say x equal to -4 is not in the domain, or look at the way the domain is written. -∞ to -4 union -4 to infinity, and this parenthesis signifies that -4 is not included. All reals are possible input here except -4. -4 is not in the domain of this function. Alright, look at the graph of this function. I want you to look at it for a while. This is x equal to -4. You can see the function graph has a break there. And watch what happens if x equal to -4.1 here. That is the output. X equal to -4.01. We are getting very close to -4. The output is very large. And as x gets closer and closer to -4, look at the language I'm going to use. X is approaching -4 from the left. Can you see that? X is approaching from -4.5, -4.4, -4.3, -4.2, -4.1. As x gets closer and closer to -4 from the left, where is the function output going? It's going towards positive infinity. In the same way, as x gets closer and closer to -4 from the right, -3.5, -3.6, -3.7, -3.8, -3.9, and it gets closer to -4, the output goes to -infinity. You see, there is a break in the function graph at x equal to -4. That means x equal to -4 does not give you a meaningful output. X equal to -4 is not in the domain. Now, how about the output of this function? How about the range? What is the meaning of range? Range is the set of all possible outputs. What is the range of this function? If you inspect this graph carefully, draw this graph in your calculator and say take a range of -1 to +2, you can see the function graph, the output can never be equal to 1. You will never get an output y equal to 1. That's right. Y equal to 1 is an impossible output for this function. The set of all possible outputs of a function is called the range of the function. Since in this case, y equal to 1 is not a possible output, we will write the range as -infinity to 1, union 1 to infinity. Again, look at the use of parentheses. It means the domain does not contain 1. I'm sorry, not the domain. The range does not contain 1. It contains all real numbers except 1. So, the domain is the set of all real numbers except x equal to -4. And the range is all real numbers except y equal to 1. Okay, let's look at another function.